Today we will solve another spectrum, that is of cyclopentane. Here the same rules. First of all, we will find the number of the peaks, as the number of the peaks tells us the different kinds of the protons or the carbon. Then we will find the chemical shift value, and then we will determine the integration values from the molecular formula or the given values. It may be given in the digitalized form, or it may be given in the scale form, or the molecular formula is given. You may also find integration values from the molecular formula if only the same kind of the protons are present. And at the last we will elucidate our structure simply. Okay, from the IR spectrum, no information is given, as no peak is present, only the peak at the 300 is given, and that is not very important. And here if you see in the mass spectrum value, the molecular formula is given. This is very important. This is C5H10. Molecular peak is also given, and some fragmentation peaks is also given. This is the base peak that is given to you. And okay, the information that we will get from the mass spectrum is C5H10. This is your molecular formula. And here in the C13 NMR spectrum, there are two spectra given. First is depth, and the second is proton decoupled spectrum. In the depth, very important information is given. As you may see here, the CH2, any CH2 group that is present in your compound, it will be in the downward in the depth spectra, and the CH3 group or the CH will be in the upward direction. And if you see here, only the downward peak is present, so it means only the CH2 group is present in your compound. Now it is very easy for you to elucidate your structure, or you to deduce your structure from the given information, that is C5 and H10. This is your molecular formula, and it is also the information that you get from the previously IR spectrum. This is no functional group is present, so now it is very simple. Yes, almost you have already know that the compound of your choice, but here in the NMR spectrum we will wait for it, and we will see here 1.5 ppm value is given, and only one peak is present. This one peak means that only one kind of the protons are present here in your structure. And the second thing is that this is the singlet peak. Singlet peak means that it is not separated by the neighboring protons, and because the chemical environment of the protons are same. And here if you see the ppm value, it is almost at 1.5 ppm value. This means that the range that is about 1.2 to 1.7, this shows that CH2 group is present, or the protons are present where that is attached with the CH2 group. So it means that this also tells you that your CH2 group is present, as your molecular formula is C5H10, and only one kind of the protons are present. So it means the integration value is here 10. It means that 10 protons. Okay, now we will see that only C5CH2 group is present, right? Because the information that you get from the carbon 13 is that CH2 group is present, and from the proton NMR it is also that CH2 is present. And why did I say that 5 CH2 groups are present? Because there are the molecular formula of C5H10, and we have to divide this formula as to make this structure. Okay, now if you see here, this CH2 group is present, CH2 group, this is fully satisfied, and fully satisfied. But this carbon and this carbon is not fully satisfied according to their valency. So what you will do, if you join these also, then is it correct now? If the valencies of these carbon atoms are now correct, is it so? Yes, this is correct. So your structure is simply cyclopentane. This is your elucidated structure. So the structure that you elucidate is that cyclopentane. Okay, now if you see here, the protons here are of the same chemical environment. That's why the splitting does not occur in your spectra. And also, if the same environments of protons are present in your structure, it means it will give the singlet in the NMR spectra. Remember this. This is also an important information that may be asked in the MCQs.